It's already over 2 years that we did a video where we recommended a book, and since then I haven't read that much, at least not or hardly technical books. And the books that I have read were not the kind I would say were worth recommending. And that has changed in recent weeks. I've read a book that I think many developers might find very interesting and exciting, and that's why today, after a long time, we are finally talking about a book again. And in this sense, hello and welcome to our new RTFM. The book today's video is called Programming Machine Learning, and this is the German version of it, written by Paolo Perrotta, and it has been published by O'Reilly Media. The book isn't brand new, actually. I've read the German edition, which came out in 2020, but the original English version was published in 2019. And these 3 or 4 years are obviously a very long time in the field of machine learning, in which lots of things have happened. Just consider the processing of natural language with the help of large language models, or LLMs, and the transformer architecture example given, which is the basis of GPT, respectively ChatGPT, among others. Within a few years, something entirely new was developed that has changed everything. But the fundamentals are still the same. At the end of the day, even an LLM is nothing more than a neural network, just one with a special architecture, with a special structure, and with a few special tools. But anyone who wants to deal with LLMs, transformers, and all these things is well advised to familiarize themselves extensively with the basics first. And that is what I personally find very challenging. Because there are indeed a plethora of books on data science, data engineering, machine learning, deep learning, scikit, TensorFlow, Keras, and so on. But the problem is, on the one hand, one simply cannot read all these books, and one doesn't know where to start, as most of these terms initially mean nothing to you as a developer. And on the other hand, many of these books are not aimed at people who come from a development background, and it shows the whole approach to what I'll call AI topics is often not explained in an analytical, structured and logical way, but rather it's more explorative and along the lines of let's just do something and see what happens. And that's not my way of learning, as I've said. I miss the structured, analytical, logical approach too much. By the way, I'm not saying AI topics don't have these characteristics. All I'm saying is just that most books don't reflect them very well, and I personally find many books therefore quite exhaustive to read. That's one of the reasons why we haven't introduced any books in the last 2 years. There simply wasn't any, as I've already mentioned, where I would have said this is a really great book, we must show it off. And that has finally changed. Programming Machine Learning is one such book where I'd say if you're interested in an introduction to AI and if you're coming from a development background, then this book is just right for you. And even more than that, I think you'll hardly find a better introduction. In general, the book, with its approximately 320 pages, is divided into 3 parts, each of which is roughly the same length. The first part is about the basics, and Paolo Perrotta does a great job right from the start with very nice and especially very vivid examples and in a very motivating and amusing tone. It starts with an imaginary friend who runs a pizza restaurant who is asking you for your help because he would like to predict how many pizzas he will sell on certain days, depending on the number of reservations that have been made. And that's what I like about it, it's tangible. It could happen exactly like that in reality. And you then build an initial solution that solves this problem. In this process, you already learn what linear regression is, what a model is, how it's optimized, what the learning rate is, and so on. In other words, you learn many basic terms. The next chapter introduces an algorithm called gradient descent, which in the book will for a long time be the standard method for trying to optimize results. And even this, despite requiring a bit of mathematics because it's ultimately about curve sketching and derivatives, is explained very vividly so that you can easily imagine what is happening and especially why things are happening. The fourth chapter, Hyperspace, where it's about calculating with vectors and matrices and where it involves more than 3 dimensions, becomes mathematically more challenging. This is one of 2 chapters that I personally would describe as mathematically quite demanding, which, by the way, the author himself also notes, and I read and thought through the chapter 2 or 3 times just to be sure, until I felt that I really understood it. The nice thing is that all the other chapters are relatively mathless in comparison and accordingly easy to read. By the way, this doesn't mean that this 4th chapter can't be read well. You just have to concentrate a little bit more here, at least if vectors, matrices and co are not part of your daily routine. Yeah, and all of this provides the base for showing the limits of linear regression and introducing the sigmoid function, which, like gradient descent, will also for a long time remain a standard function in the book. With this, a binary classifier is then built, that is, a model that can divide inputs into 2 different categories, and this is done with a relatively well-known MNIST dataset, which contains thousands of handwritten digits to be recognized by AI. And after the author has shown how this works for a single digit, he finally expands the example in chapter 7 and introduces one-hot encodings, which allows all 10 digits to be processed and recognized at the same time. And all this culminates in the introduction of the perceptron, a kind of simplified neural network with a small historical context, and that then was the first part. And even if you only read up to this point, you already have a very good feeling for how machine learning basically works. You know a whole range of basic terms, but also some problems that arise in practice. You have already implemented all of this yourself, and overall it's a really good and quite good introduction. Part 2 then starts with building a proper neural network, which is far more complex than the simple perceptron. And on this occasion, you get to know concepts like the softmax function and cross entropy. What I find very exciting here is how they approaches the second part, because he first builds up the neural network without worrying too much about how it should be trained. He deliberately pushes these considerations a bit back until you hit the second very math-heavy chapter in chapter 11. This time it's about backpropagation. Actually, I find this chapter far more demanding and challenging than the 4th one, which was about hyperspace. Maybe the question might arise whether one really needs to completely understand the mathematics of this chapter, or whether it's enough to have understood the basic concept of backpropagation and have seen potential problems such as dead neurons and similar things here. At the end of the day, however, everyone has to decide this for themselves. Bottom line, I believe that even if you rather skim this chapter and skip the mathematical parts, it doesn't change much in the overall understanding of the entire topic and the entire book. From here on, however, it gets a lot easier again. The next chapters are about how to improve the results of a neural network. And this covers a whole range of aspects. For example, it's about how to evaluate the performance of a neural network at all, because this is not as easy as it initially seems to be. It's about how to prepare the data in the beginning. It's about how to optimize the network's hyperparameters like the learning rate, the number of nodes, the batch size, and so on. And the nice thing is, although these are all relatively arid topics, they are presented very vividly in the book, so that you, at least that's how it felt for me, really enjoy reading these chapters. And overall you get a, in my opinion, pretty good set of tools at hand, especially for the beginning, to be able to build and train neural networks, but also to configure and to adapt them in a somewhat targeted way for practical tasks. And that's worth a lot, because that's one of the topics that are often neglected in other books, or where it simply says you have to try it out, or it's a matter of experience. And programming machine learning does a very, very good job here. And that's also where part 2 ends. Part 3 finally then dedicates itself to deep learning. That is, it first explains what deep learning is and how to get to neural networks with additional layers at all. And very importantly, from here on, you no longer write all the code from scratch yourself, but from here on, Keras is being used. And Keras is a library for Python that makes it very easy to build neural networks, and that sort of acts as a convenience or as an abstraction layer over TensorFlow and PyTorch. And this means you can use their performance, but you don't have to directly deal with them, but you can use a simplified API with Keras, which makes it a lot easier to get started. And that surprised me a lot and made me very happy, because honestly I imagined the whole thing to be a lot more difficult, and with all the basics you've learned up to that point, at least getting started with Keras is pretty simple and obvious now. What you learn in connection with deep learning, however, is that deeper networks tend to overfit very quickly. To prevent this and generally avoid some problems with deep learning, concepts such as regularization and batch normalization and, for example, other activation functions like ReLU are introduced. The book also deals with alternatives to gradient descent, such as RMS-prop and ADAM. And thanks to Keras, all of this can be tried out quite easily, because in principle you only have to change a function reference here and there, and that's it. Well, and then there are the last two chapters, which give a bit of an outlook. Chapter 19 scratches convolutional neural networks, at least on the surface, and in chapter 20 a few advanced topics are touched upon, for example recurrent neural networks, long short-term memory, support vector machines, decision trees and so on, just to give you as a reader a few keywords to show in which direction, or rather in which directions, you could now continue independently. And that, in my point of view, is the real merit of this book. It really conveys the basics in a way that everything logically builds on top of each other, and it guides you quite naturally to the end, where you end up thinking, wow, I've learned a lot, but I didn't notice that I was learning. And the fact that you have to go through the two very math-heavy chapters is inherent in the nature of the subject, but I think the really important point is there are only two chapters designed like that, and all the others read very fluently, very pleasantly and very vividly. And the book left me personally with the feeling that I now have a much better and especially a much more detailed and reliable understanding of what many terms are about. I actually knew before how neural networks work, but the book taught me an incredible amount of details and important minor things that helped me to assess the topic overall much better, and especially to apply it in practice. And therefore, for all the reasons mentioned, I believe that programming machine learning is a really good recommendation, and that every developer who is interested in these AI and machine learning topics should take a look at this book. Oh, and one last thing. Yes, the book uses Keras. And not only for this reason, it also uses Python. And now you might be wondering whether the book is suitable for you, because you maybe have little or even no experience with Python. And I can reassure you, I myself also only have very shallow experience with Python, and yet it was not a problem for me at all to read the book and to replicate and apply the examples. And in that respect, I believe that it's not really an obstacle. If you have already read the book, or if you are now going to buy and read it in response to this video, please write in the comments what you think of the book, whether you share my enthusiasm, or whether there are things you would have wished for in a different or maybe in a better way. I would be very interested in that. Yeah, well, and independent of that, all that remains for me to say is that if you liked the video today, I'm of course, as always, happy if you share it with your colleagues, and I wish you a good start to the new week, and as always, take good care of yourself, stay healthy, and then we'll see each other again in the next video, and in this sense, bye.